Welcome to the video on Chapter 20. We're going to talk this time about in-context assemblies. I'm showing you this simple assembly with two parts, and it has an out-of-context component right now. I'm going to delete this and recreate an in-context component. In-context means that a new part is being built with a relationship to an existing part in the context of a particular assembly. This new part will depend on the existing part that's here, the box bottom, and it will also depend on this assembly because of the spatial relationship. It can only be created in the assembly. So we've got a box bottom and we want to create a box top. Here's how we get started if we're going to create this in context. I'm going to insert a new component, and the first step in creating a new component in the context of the assembly is to select the face or plane on which to position the new part, and I'm just reading that from the lower left-hand corner, and the cursor has a check mark on it. That means it's looking for something. Now there are a couple of different ways I can go with this. The first thing I could do, and you might be tempted to do this, is just click right on the face of the existing part. Now that's one way to go, but if we do that, then that's going to create a reference between our new part and this existing part. It might be safer and create fewer references if we just use one of the planes here. And it just turns out that we're lucky that this plane is right at the level of the top of that face. So I'm just going to go ahead and click on the top plane. So that means that the front plane of this part that I'm creating is going to be created on the top plane of the assembly. Okay, so the first thing SolidWorks does after I select the plane is it kicks me into a sketch. And here's what I'm going to do. I'm going to select this face after all and use my convert entities to get that edge that goes around. Now I'm going to do something that might surprise you here. I'm going to let's extrude this, but let's extrude it as a thin feature, and let's see, establish a width for that, and then establish a depth. And we want the depth to go the other direction. Okay, so we're creating a tight-fitting lip around the outside. And we'll say okay to that. Now, if we look at this part, we've got a feature and we've got a sketch. And look at this symbol that it has there. It's got a minus and greater than sign. It's supposed to be an arrow, but created out of text. This symbol means that there's a relationship between this sketch and something external to the file. We can right click on that and say list external references, and it will tell you that it has an external reference that's made in this particular assembly. And then it's going to tell you exactly what those references are. It's a set of converted edges from the box bottom part to the new part, which is a virtual part, hasn't been named yet. If you're ever wondering where your references are going, that's where the reference goes. Now look, we've got several other controls down here. We've got a break all, lock all, and unlock all. As far as I'm concerned, this break all should just simply not be there in the software at all. You don't get any advantage of using the break all relations that you don't get from the lock all. Lock, you're able to unlock, but once you've broken something, you can't just put it back together. So don't use break all, always use lock all if you're going to do this at all. Okay, so we'll say, I'm just going to leave these active because what's the sense in making an associative relationship if you're not going to use it? And if you're just going to delete it later on? I'm going to go back and make a change because if I just extrude this again to make the top, there's one of two things I could get. The first thing I could get is a zero thickness error. That's one thing I can get. The second thing I can get would be two bodies. So let's do this. I got two solid bodies. Why did I get two solid bodies? They come together here at an edge, and an infinitely thin edge. So that's what we call the zero thickness, and CAD has a real hard time dealing with this sort of geometry situation. So whenever it happens, SolidWorks is going to tell you that you have a couple of options. One of them is that the feature fails, and the other one is that you get multiple bodies. Anyway, so to avoid that, what I'm going to do is go back to the first feature, edit the feature, and tell this that it's going to go in direction 2. Also, we'll make that 2 millimeters tall. Say OK. I can turn on the merge result feature, which turned itself off automatically, and now I just get a single body. You have to be really careful about SolidWorks because they're so afraid of presenting the user with an error that they will do things automatically for you behind the scenes, and if you don't know what it's doing, you may have trouble fixing what they've done for you automatically. So we're a little bit off track here. We're supposed to be talking about in context, but we're winding up talking about multi-bodies. So now we've created this in context part. We have in context markers, and there's something else that SolidWorks has hidden from you because it causes too many tech support questions. Okay, so down here we have show update holders. What's an update holder? Well, an update holder is this. Every time you create an in-context relation, SolidWorks is going to make a folder that associates this part with that part, and it does it in this assembly. And then it also has to reference the edges and the particular sketch plane from the new part and all that. So this feature, or this what they call update holder, is going to tell SolidWorks what has to change in order to keep this relationship going. Let's show you how this doesn't work, and then we'll show you how it does work. I'm going to open up this top part that we just created. And if I go into this sketch, the sketch has relationships to stuff, but you can't see what it is, and it's fully defined. So you cannot change this sketch right here without deleting some of the in-context relations, okay? Because it's controlled from the other part. This is important to remember, especially if you're new to this stuff. Okay, so the only things that you can change are in the features. So you can change the depth of this, you can change the thickness of the thin feature and whatnot, but you cannot change the size of the lid. One thing I might want to do is add a 2 millimeter shell to inside of that. Okay, so that's nice. Okay, so I can add features, but now in order to change the size, I'm going to have to go back to the assembly, double click on the main box, say I want to make this now 4.5, and I'll build it, and the lid updates. Double click on the width. Let's make this, let's make it 4. Pull this out of the way, hit rebuild, and you see the lid update with it. Okay, now here's the limitations on this sort of thing. Let's say you now put this in a subassembly. So I take all of this and I say File, make assembly from assembly, and I make myself a new assembly and put this part in here. All right, Now I want to create a new part. Insert new component in the context of this assembly. And I'm going to click on the top of this box, click on the lid, and do an offset maybe. Let's see, let's reverse that. And there we are. All right. Now I'm going to take this and extrude it. All right, whatever I'm doing here. Okay, now the colors are the same, but I've got different parts. I've got my original subassembly, which is made up of the box bottom and the box top, and those have an in-context relation. And then I have my new part that goes on top in another subassembly. So what we're starting to do here is create a problem. And these are the kinds of problems that you need to really be aware of when you're working with in-context stuff, because you're creating relationships between parts in the context of an assembly. And now, if we take a look at this top that we built, and we open this up in its own window, we have this feature, which is being driven by the other part in the other assembly. So we can go back here. So it's being driven by that part, the purple part in the original assembly. And then we've got this top part, which is being driven by this part in this assembly. So these SolidWorks keeps track of all of these things, but really, can you? Can you understand the relationships that are going on here? If we change this, say back to 3 inches, what happens? All right, both parts change. But if we only had this assembly open, and we change this to 6 inches. All right. This part is opened, or this part has changed, but the other part will not have changed. So if we go back, I've got my settings set so that everything rebuilds. If you have an assembly that's larger than a couple of parts, this can produce some problems for you. So what I'm trying to say here in a long-winded sort of way is that you really need to have a plan when you're going into an assembly and you start to create in-context parts. Notice we've got an update holder here and then another one at a different level in an assembly, and in one assembly, this part is the child, and in another assembly, it's the parent. So that's going to cause a cascading rebuild that SolidWorks is going to have to deal with. And now let's say you've got multiple instances of these things, and maybe you've got a place where this is used in another assembly without the bottom. What's going to happen if you need to change it there? So that's another issue that you're going to have to work through as you work with in-context relations. Remember, the couple of things that you need to remember here are these update holders. You can right-click on the top-level assembly and either hide or show the update holders. They are hidden by default because SolidWorks gets too many tech support questions if they don't hide those things. So let's hide them. And the second thing that you need to be aware of is how to get the external reference information and what this symbol means. Okay, so those are the basic ideas that go into in-context assembly modeling. and you'll need to apply those ideas and others as you start making real-life assemblies at a much larger scale and with higher consequences if things go wrong. So best of luck, and we'll see you in the next chapter.